Welcome to online video training for the CTI Workbench Integrated Development Environment. Course 1, Part 8. Other topics. Running time, 19 minutes. In this video, we'll learn how to use the built-in tools in Workbench for visualization and troubleshooting of our project. Those tools include graphical displays, charts, trend charts, and remote target web pages. We'll also learn how to download project source files to the target, and how to restore a project from those files, if the source files aren't available on your PC. Finally, we'll see how to use password protection on the runtime, and on individual programs. Workbench graphics allow you to build simple HMI displays for diagnosing and troubleshooting your application. These displays can be viewed in Workbench, or, with a C2000 series CPU, they can be viewed over the network using a web browser. To create a graphics display, highlight the folder where you want to create it, right-click, and select Insert New Item. Select Graphics from the list of available items, and click Next. Enter a name and description for this graphics display. We'll keep the default. Click OK, and the new graphics display is created in the project tree. This graphics display will be for Ladder Logic Exercise 1A, where we implemented a conveyor control. Double-click the item to open for editing. We'll start our display with a text label. From the graphics object list at the right, expand text, and select static. This will let us put a label on our display. Drag it over into the display. Double-click the item to edit it. Change the text to read Conveyor 1. Note, on this box you can also edit text color, font, and size. Click OK to save and exit. We'll resize the object, so all the text shows up. Next, we'll add a conveyor run indicator. From the object list, expand shapes and select ellipse. Drag it into the display and make it a little smaller. Double-click to edit. Change the text to read, run. Change the text color to white. Change the true color to green. And the false color to red. Click OK to exit. Then, we'll attach a variable by dragging the Conveyor 1 run variable from Exercise 1A. To add a Start button, expand the switches, and select Push button. Drag it onto the display and double-click to edit. We'll change the text to read, Start. Make the text white. Set the background to green. This time we'll assign the variable by editing the variable symbol field, and selecting the Conveyor 1 Start variable from Exercise 1A. Click OK to exit. Repeat this process for the Stop Push button. Make the background color red. And assign the Conveyor 1 Stop variable from Exercise 1A. Now add the safety stop. Make the background red. Change the action from push button to switch, since this input is not momentary. Click OK to exit. And attach the Conveyor 1 Safety Stop variable from Exercise 1A. Finally, add the overload switch. Make the background red. Change the action from push button to switch, since this input is not momentary. Click OK to exit. And attach the Conveyor 1 overload variable from Exercise 1A. To test our graphics display, we first have to compile the project. Then go to Simulate. Click Start to start the conveyor. The run indicator goes to green. Click Stop. And it goes to red. Now check the safety stop. Works correctly. And the overload. Also working. As you can see, building a simple graphical display makes it easier to test the project, compared to manually setting variables. With a little more time spent in drawing and configuring the diagram, you can make graphical displays equivalent to basic HMI devices. Here's an example using an imported bitmap of a conveyor, with controls and indicators overlaid. To aid in debugging, Workbench allows you to build predefined charts of variables, which can be displayed for monitoring and editing during runtime. These charts are called SPI lists in Workbench. There are two places where SPI lists can be created and stored. One SPI list associated with each program, and unlimited SPI lists stored in the workspace folder hierarchy. To create or edit the SPI list associated with a program, double-click the program to open it for editing. In the Details pane at the right, make sure the SPI list tab is selected. Then drag down the desired variables from the variable list above. Once your SPI list is completed, you can test it in simulation mode. During runtime, the value of each variable is constantly updated in the list. You can edit the value by double-clicking to open the Edit dialog. You can also create SPI lists which are stored in the workspace folder hierarchy. You can organize these however you like. To create a SPI list, right-click in the folder where you want the SPI list to reside, click Insert New Item, then click SPI list from the list of available items. Enter a name for this SPI list and a description. Click OK, and the SPI list is created. Double-click the SPI list to open it for editing. Then just drag the desired variables into the SPI list from the Variables pane. During runtime, these values are continuously updated, and the values can be edited by double-clicking to open the Variable Editing dialog. Another very useful visualization and troubleshooting tool is the trend chart, or soft oscilloscope, Softscope for short. The Softscope enables monitoring of designated Boolean or numerical variables, and displays the values in a trend chart. Monitored variables are tracked by the runtime, which detects changes and assigns timestamps, so that the trend displayed is very accurate. Running under Workbench, the trend chart can plot values over time, and allows you to scroll backward or forward in the plot. Data can also optionally be logged to a file on disk. To create a Softscope, right-click on the folder where you want to create it. Click Insert New Item. Then select Softscope from the list. Enter a new name and description for this Softscope. We'll call it Softscope 1. The Softscope will be added into the folder hierarchy. Double-click on the Softscope we just created, to open it for editing. To add variables to the chart, just drag them from the variable pane on the right. They will appear in the variables list at the top. Once you have added the desired variables, you can configure the appearance of each variable by editing the parameters in the columns. You can set the plot color for each variable. We'll set output 1 to red and output 3 to blue. You can set a gain and offset for each variable, and you can set the minimum and maximum axis values. In this example, our variables are sinusoids, so we'll use -1 and +1 for each variable. These values can also be changed while the trend chart is running, as we'll see in a moment. Let's have a look at our trend chart during operation. We'll compile the application and go to simulate mode. You can see the application is running now, and the output variables are being updated. To start the trend chart, click the Start Sampling icon to the left of the chart. The trend begins updating, showing our 3 sinusoidal outputs, which each have different frequencies. We can use the Setup Curves icon to change the refresh rate. And now our trend updates more quickly. If we want to look back in time, we can stop auto-scrolling using the icon. Then we can use the manual zoom and scroll, at the bottom of the trend chart, to look at any part of the trend. We can also change the way the trends are displayed, by editing the diagram number for each variable. Workbench can log variables to a disk file during trend chart operation. Click the record sampling icon, then specify the file where you want the data logged. You can stop logging by clicking the record sampling icon again. Stop the trend sampling. Once it's stopped, you can save the trend chart to disk for later reference. Another useful troubleshooting tool is the module web page, which is included on all CTI products running Workbench applications. The web page can be used for configuring the product and viewing troubleshooting information. To access the web page, just type the target IP address into the URL box in any web browser. The event log page records significant events that occur during the startup and operation of the module. The product information page contains information about the module hardware, firmware, and current configuration. The module configuration page includes user settings for parameters such as IP address, startup operation mode, and system time source. There are many other pages, which are specific to each target device, including extensive debugging information about network and communications activity. The Display All Statistics page includes a complete set of diagnostic information which will be needed by CTI technical support if you call for help. Most browsers will allow you to save the page, which can then be emailed to your support contact. Workbench has the ability to store a complete set of the Workbench project source files on the target. This feature can be very helpful as a fail-safe backup for your project. Even if something happens to the copy on your PC, you can still recover the original project from the target. There are two ways to manage this feature. You can edit the download procedure in project settings to force automatic download of source files each time the project is downloaded to the target. Or, you can manually save the project to the target. Automatic downloading can be configured in project settings. Right-click on the project name and select Settings. Under the Debugging category, edit the download procedure item. Click the box at the bottom to send source code. Now each time the project is downloaded, a set of source files for the project will be stored on the SD card on the target device. You can also do a manual download of the source files to the target at any time. Just right-click on the project name, then select Save Project to Target. A confirmation dialog box will be displayed, confirming the target IP address and the list of items to download. Click OK to complete the download. If you have saved the project source files to the target, it's easy to recover them. Close any open workspace. Then click File, Add Existing Project, from Target. The Open Project dialog box comes up, to allow you to enter the IP address of the target, the disk folder for storing the project after it's downloaded, and a new name for the project. We'll call it Test Restore. Click OK to proceed. The project is downloaded from the target, and the workspace opens, ready for editing. Note that you are not editing this project directly off the target. Instead, a copy has been created on your local drive for editing. Workbench includes several levels of password protection. You can protect the entire runtime system, so anyone connecting to the runtime with Workbench must provide the password. To set a runtime password, right-click on the project name, and select Project Settings. In the compiler category, double-click on Runtime Password. Enter the desired password, and click OK to proceed. We'll compile the program. Connect to the target. And download the new version. Disconnect. And then reconnect. And now we're asked for the password. To clear the password, we'll disconnect. Then edit the project settings again. And put in an empty password. Recompile. Connect. We must provide the old password, because it's still active in the target. Now download the new version without a password. Then disconnect and reconnect to check. This time, we're not asked for a password. You can also password protect individual programs. When a program is password protected, it cannot be opened for viewing and editing. The protection must be removed in order to open it. To set a password on a program, first close it, if it's currently open. Right-click on the program, and select Properties. In the Security tab, click Set Protection, and enter a password. Click OK to exit. Now if we try to open the program, we get a message saying it's password protected. To clear the protection, right-click on the program, and select Properties. In the Security tab, click Remove Protection, and enter the password. Click OK to exit. Now we can open the program. That completes Course 1, Part 8, and concludes Workbench Training Course 1. Here's a summary of what we've covered in Course 1. Introduction to Workbench and IEC 61131. Basic concepts of Workbench. Getting started programming in Workbench. Programming in ladder diagram. Programming in function block diagram. Running on a remote target. Using the field bus editor. Using built-in tools for visualization and troubleshooting. Downloading project source files to the target, and restoring the project from the target. And using password protection.